All right, welcome to the third video on file format reverse engineering. In this one, we're going to be taking a look at templating with O&O. Now, there's a few reasons why we want to template with either O&O or struct is that it's actually going to give us a better way of documenting the file format than just making notes in like a text editor. Another thing is going to force us to understand the fields, and it's going to allow us to parse them a little bit easier. It's also going to allow transitioning from the templating to some application that parses or writes the file or modifies the file that we're reverse engineering a lot easier. So when we're templating, I'll show you kind of a thing why this is really nice. So here I have this sweet stance GTI picture here, and what we're going to do is drag this over here, and there's a really nice new feature in O&O. It's actually been around for a while, but it has a repository. It'll understand what file format we're loading and ask you if you just want to go ahead and install that specific binary template. So in this case, we'll go ahead and agree to all this stuff, install that, and now our JPEG has a broken down field here. So the template has executed successfully, and it's highlighted all the individual fields for us. So if we take a look at what happens when we template, one, we've noticed that it'll highlight colors for us if we set it up that way. And it'll also allow us to drill down to specific fields. So in this case, it tells us what the field might be called. There's this app0 field, and then the entire thing here. And we can keep going down, and it'll actually select the individual components of this. So for example, this is a char of 5 bytes, and it ends up being just the JFIF0. And this will continue down through the entire application. This is all of the data, and at the end marker. So this will allow us to structure all of the information that we know about the file as we start going on. And sort of developing up our understanding of the file format. So when we start doing this, one of the things that we want to look at is the documentation for O&O editor. So up here under support, we can go to online manual, and one of the fields is templating or templates. There's a whole section on writing templates. So we go to the basics, and one of the things that we'll want are structs and unions. And it'll kind of show you, it's very C style in that you can do a lot of things with this. There's expressions and bit fields that you can do, a lot of conditionals. So if we look at templates, open template, we can grab, for example, the bitmap template and open it. And it'll show us how this is structured. So this is the entire template for parsing a bitmap file. It's not too crazy, and it's actually pretty straightforward if you have some like C experience. A lot of this will sort of make a lot of sense to you, and it'll probably be pretty familiar of how to work with this templating files. So what we're going to do is start mocking out what this cards.dat file could be. And we're going to go back to our process monitor capture, and I've gone ahead and added a new filter for the path, which is this location up here that contains .dat, and that's filtered everything down to only have things that have had .dat with them. And notice that there's a set4 temp files, gamebot v2, slot 3, cards.dat. I'm looking at slot 1 right now, and there's some in slot 2, but I want to understand what this particular thing might be. I'm not exactly sure what slot 0 is. I think slot 0 might apply to all of these, but inevitably, like inside of the actual game, there's 3 save files or slots that you can have. So under each profile. So if you create a profile for one player, you can have up to 3 characters, and I think that's because there are 3 classes. So if I wanted to have 1 hunter, 1 rogue, 1 warrior, whatever it is, I could do that. So under this right now, we can see that at This location for the detail, it tells us that there was a write file operation on cards.dat at offset 3 and the length was, or at offset 0 and the length was 3. All right. So the next write operation was at offset 3 at a length of 46. And it continues down this way to give us an understanding of what this application might actually be doing and how much data is actually being written at that point. So if we take a look at this, we can actually start getting some information about what the logical chunks in our file might actually mean or represent. So if I go to templates, new template, it'll give me sort of this like starting template here, and I can kick this off by defining a struct, and I'll just call it like ret2 games profile or something. All right, and the very first thing I want is char, and I'm just going to call it magic. I'm not exactly sure what it is, but it looks like it's going to be 3 bytes. All right, so I'll do the R2G profile. I'll just call it profile. So we're going to define our structure up here, and then we're going to basically define or say that we're going to initialize one instance of the structure here. So I'll save this. And I want to save it to, let's see, desktop under templates, and I'll call this cards. Cards.dat. Cards.dat. Okay. Actually, instead of profile, we're going to call this R2G cards.dat. All right, and then if you hit F5, it'll run it. It tells us we have a syntax error, so I need to end this. Another syntax error. There we go, and that. So our template ran, we have our variables here, and there we go, finally popped up. And then we have our 3 things. So if I highlight this under the magic, it highlights the first 3 bytes, and then just shows us what those are in that specific type. So why did we choose 3 bytes? Well, we chose 3 bytes because we have this first write up here was an offset of 0 and 3 bytes. So I want to start just kind of chunking up the first few sections here to see whether or not they make sense. The next one is at offset 3 for a length of 46. So let's go ahead and add that. Do char unknown 1. I'm going to give that a size of 46. Okay. All right. Minimize this a little bit. Rerun that. There we go. So this, once I highlight the 46 chunk, it looks like it'd be kind of weird to have 3 bytes. Like typically I would expect 1 byte, or a short, which would be 2 bytes, or an integer, which on a 32-bit application would just be 4 bytes, or like a D word. These are the things that I would expect, not 3 bytes. But when we go to an offset of 3 and select a 46-byte chunk, like it's done over here for the write, it actually aligns perfectly with this health potion, which might indicate that it's actually true. So why don't we keep going on for a little bit? So at offset 49, which would be our 46 plus 3, it has a length of 25. All right. So we'll do this char unknown 2 or unc2, and I'll set that up as 25. We'll see what happens. Run it again, highlight this, and now all of a sudden it brought us down to here. Doesn't really seem too interesting. I wouldn't really guess that that's the right offset, but Let's go ahead and try a little bit more here. So that's that. It also has an offset of 49 at 4, but I'll continue on a little bit more. At 79, it takes the length of 4. So 79 would be the location here. It's position 3. Actually goes to 79 and then writes 4 bytes. All right, kind of strange. What? Oh, goes to 74. All right, so now let's go to the next offset, which we had 49, and then it goes to 74 and writes 4 bytes there. So 74, if I run this, back at this location, that's our offset of 74. The next 4 bytes would be this, which would just be little endian 1. So that seems okay. So we just do an int and then name it like num1, since I have no idea what these things are. I'm just trying to block out what the actual thing might be. So now we have the whole amount of information that we actually have right now is just this number of bytes. And then we have this magic section, this unknown section, another unknown section, and then this first int here. So after that, we can go down to offset 78. And that's going to be a length of 1, which is really interesting. Not sure why we'd have just a single byte here, but we'll go ahead and do that. So we'll do a char at what byte might be 3. Okay. There's our unknown byte, and then at 78 or 79 it does 44. Okay. So then our next chunk is going to be a char. And it's going to be unc. Let's call this byte1, unc3. And then the value on that is going to be 44. Size of 44. Run that again with F5, and now we have this chunk. Doesn't really line up with what I sort of expected at the end of this common. But then we have the rest here up to that point. So what we want to do is continue this whole process down this, and then what we might notice is sort of a repeating pattern. Now I see a 46, a 25, there's a 48, a 25, another 25, and I don't really see too much of an individual pattern here, but what we might be able to do is collapse all of this, or some type of logical chunk that continues to happen maybe for each type of card, into blocks, and then just name that as its own structure, and then define like a certain number of those cards or structures after that. So what I'm going to do is pause the video, go through a few more of these kind of iterations, and then come back and take a look at sort of where we are, and then we can look at digging a little bit deeper. All right, so I've spent a little bit of time kind of going through a few of the lines here to build out something like this. Still not perfect. I'm nowhere near having the full file format reverse engineered, but now I'm starting to notice a pattern. Right now I call this a magic just because usually files begin with some type of magic number or identifier, but I don't think that's what's actually going on here. And the reason is I started seeing these two like chunks that are of different sizes, followed by an integer or 4 bytes, and then 1 byte. And then 2 chunks of various sizes, followed by an integer and a byte. And we'll see that this format, or this kind of chunk here, like this pattern, replicates itself, right? There's a cycle here. So if I come back to the file and hit F5 to run it, what we'll see, I can highlight all of this, and this is what I have in my structure right now. The very first thing is going to be this magic, which we'll kind of forget about that for now. Then I have this chunk of 46, then 25, then a number, which is 0, and then a byte, which is 1. If I go to the next byte, it's 2. and the next byte after that is 3, and the next byte after that is 4, the next byte after that is 5. So obviously there's some type of interesting pattern going on here, and maybe it's like the first card in the database is what ends after this. So now the question is, how on earth do we know, or does the application know, that this first chunk is going to be 46 bytes, and this is going to be 25, and this is going to be 24 bytes, and this is going to be 25, and then 37 and 20. They're not the same size. So what we want to do is go sort of like to the beginning of these. So I'm going to click on this first 46. And what I want to notice here is if I go to this location, this 4B, in my inspector, it tells me that 4B is 75 bytes. So I'll start right after that and select 75 bytes. Look at the bottom of my screen where it shows me the number of bytes selected. So go up to 75. So selected is right here. And lo and behold, it's actually brought us up to the boundary of the next chunk. And I can tell that, but if I go in here, it actually selected that. And if I go back here, well, that's not all selected. I have to select all of these things. But basically, the boundary actually exists from this byte to this one. So if I come back here all the way up to this, there are 75 bytes selected, and this 4B is the total number of bytes. So what I can actually do is there's some type of reason why this is 46 and 25. I don't know why it chose to write them like that, but I can actually fold these into this process here. So what we need to do is essentially do this magic, or whatever these first 3 bytes are. We'll just kind of forget that for now. We need to get the value of the next byte. So I'm going to go ahead and take this. Let me see if I can do. Doesn't let me. Do like formatting of all of this stuff. Let me just copy this out real fast. So now that you know that there's this pattern, instead of just trying to figure out what this number is here, I'm going to get the next 1 byte, and I'm going to call that size. All right, and then we'll run this. This is going to be off a little bit because I've added 1 byte into this. And then what I want to do is get the size, and then put it inside of this onc. So we can do something like this, and then run it. So now we have this magic 3, the size of 75, and then this next chunk of 75. And then we have this number. So let's see, that 75 actually includes the rest of everything else, I think. So that includes the number. So we would have to take the size minus 5, which would be the integer, and then the next one. So all right, and then if I highlight this guy right here, I think that brings us up to the next one. So let's try doing this. Next guy, I'll call this size 2, this size 1. This would be num2, byte 2, size 1, size 2. All right, let's run this again. And I have a duplicate array. So I've named onc1, onc2. Run this one more time, go to my variables. All right, then we have byte 2, byte 1, byte 2, byte 1. Okay. All right, cool. So now that that's going on, I think what I can actually do is pull this char out of this guy. So I'm not exactly sure what that is. And then just call this card_stat1, or maybe card1. And then create another one and call that card2. And then I'll create this size, unknown, some integer number, and then another byte, b by t. Okay, let's run this now. Size 1 is undefined. All right, So notice how it's like really quick to just kind of play around with this rather than having to write it into some application that parses all of this stuff. So this is looking good right now. I have two structures here, and what I can do is there's probably something in this magic up here probably defines how many of these there are. Maybe there are 40. 40 looks like a lot. So I'm not sure if it's definitely more than 6. So let's just do this just to kind of see what's going to happen here. 6, 7, 8, 9, 10. Obviously, I don't want to actually do this. I want to figure out how many cards there are, either by dividing it by some type of size, or maybe the very bottom of the file has like how many of these things are going to actually show up here or something. All right, so let's run this one more time. Then here we have card 10. Okay, who knows? There might actually be 40 cards in here, which would actually say like what this value is. Maybe this is a version number, the first byte, and then the number of cards that actually exist in this thing. So let's try doing this. All right, so if you run that again and then go all the way down to the end, all right. So it looks like there are 40 cards. I think I might be like off a byte or something somewhere, or maybe this last card number. I go into this structure, it tells me -1. Maybe that's some type of signal that says, hey, this is the last one. There's a 79. This last byte is a 70. At some point, it seems to kind of fallen apart. So maybe this -5 is incorrect, but it seems like this 28, which is actually a 40, is an indication of how many of these structures we should actually define in this set. So I think we can actually kind of build that into this now. All right, so I paused the video for a minute just because I forgot how to specify this. So it's kind of a weird thing inside of these templates is I renamed this to card number. Spelled card wrong. And then inside of here, normally I would take, so I remove the concept of this magic numbers. We have Onc1 is the first byte, the number of cards or number of chunks, like the number of this structure, and then some other unknown, which I'm not sure exactly what it is, right? And then we want to be able to initialize or instantiate a certain number of these structures inside of this. So if I save this and hit F5, it tells me that it went off the end of the template, but then it tells me, warning, line 25, optimization array of structure may cause incorrect results. Use optimize true or false. The format for that is actually just putting that right after but before the semicolon. So we say don't optimize this structure, which might actually just be padding this out into to the next 4 bytes or something like that, which caused it to actually run off. So if I run it again, everything works fine or as expected. And then when I come back here, I have 40 chunks. And then going down to this 0 index, we end at 39. So at this point, everything sort of looks fine. The one thing that starts to be a little strange is I have 4F at the end of this guy, which is like my card number is 79. And then before that, it's 70. And then 69, 68. Okay, so things start to look good. At some point, the very last, second to last one, ends up going 69 to 70 to 79. And I don't know why it doesn't go to like 71. Let's see. Yeah, I just don't get that. And then the last one might just be an indicator that says, hey, we're out of cards here or something. So this num, I don't see any values inside of num that are non-zero. So it's kind of hard to tell what that could actually be related to. Maybe it's some type of padding or just reserved byte for something. It might also represent an upgraded card. Cards can be upgraded at like one of the NPCs. So perhaps that's like the level of upgrades that it has available to it or something. So at this point, we know that we have got some information here in the form of this a certain number of times. What I don't know is sort of we have this size, how to break down the information in here. So I think what we can do is actually modify this a little bit more to understand how much or the different amounts of data that actually go into this. So all of this again sort of stemmed from doing this. Now if we want to start digging a little bit into the application and figuring out where this stuff comes from, like where it's actually being written to, there's a feature inside of Process Monitor that's really nice that'll allow us to dig into that, which we'll take a look at in the next video, digging deeper, locating parsing routines inside of the application. We'll see you then.